Hi, so here is another exciting example under line integrals. So we are now told to say we have to evaluate this, we have to evaluate what we have here, okay? Where C is the straight line, um, have I written the correct thing here? Okay, that's supposed to be straight. Um, just give me a minute. Straight line segment, okay? So, and we are told that it is from this point here that we have, that is 1 comma 2 comma 3 to 0 comma negative 1 comma 1. Okay, so one thing that we have noticed here is that first of all, we have not been given in terms of our vector valued function, where you can easily pick your x of t, y of t, as well as z of t. And as well, we have not been given, we have not been told um, directly what the initial, like the lower limit is and the upper limit. Remember to say in the previous examples we have talked about a situation where we're like this, we are moving from 0 to something like this, let's say to 1. There another one, I think it was like from 0 to, not 0, I think it was 1 to 1 to infinity. We have not been given in this form, so we have to try to figure it out. Okay, so I'll try to explain that, um, just in case you might come across questions of this nature. Okay, so the first thing that we have to do is we have to um, we have to write the parametric equation of the line segment that we have. Okay, so just have to write the to get the x of t, y of t, and z of t. Just write the parametric equation for the straight line segment, which is from those points that we have. So what you do is just to come up with a vector. So let me say the first point is a, so we say a is equals to 1 comma 2 comma 3, then b is equals to 0 comma negative 1 comma 1. So it simply means my vector AB is simply going to be equals to negative 1 comma negative 3 comma negative 2. How am I getting this? There is 0 here and there is 1 here. All I've done is I've just said um, 0 minus 1 comma, then there's negative 1 and there's positive 2 there. Then I've said negative 1 minus 2, okay, comma, all the same I say 1 minus 3, hence that's how I ended up with that. Okay, and actually I need to use uh, this type of brackets. Then we say we have negative 1, we have negative 3, and we have negative 2 there, like that. Okay, so what this tells us now is this. Okay, what this tells us is that our x, okay, it's more like, let me just write it as x of t for convenience's sake. My x of t will be equals to I'll pick any of these points. Let me use point A. I can say it's 1 minus 1 minus t. Why am I saying minus t? It's just this one, because it will be this point plus, okay, this vector multiplied by t, which is our parameter there. Okay, so then what about my y? My y of t will be equals to this point that I have here. Okay, this point that I have plus, but because there is a negative here, this will just be minus 3t. Then let's talk about our z. Our z will be equals to, what do we have? We have a 3. So this will be equals to 3, then that will be minus 2t, something like that. Okay, so from these we can come up with our, we can actually come up with our lower limits as well as the upper limits. So for the x, we have x of t is equals to 1 minus t. um, then y of t is equals to 2 minus 3 of t, sorry, 3t. Then z of t will be equals to 3 minus 2t, like that. So before I do the differentiating here, let me go ahead and determine my lower limit as well as the upper limit. So to get the lower limit, I'm just going to use a, because you're moving from a to b. Okay, so the my a will give me the lower limit. Then to get your lower limit, you can use any of these functions. Okay, you can use any of those functions, it's still going to give you the same thing. So for example, if you want to use x, okay, that will be like you're saying your x is equals to 1 minus t. You can get what your is here. Your x is what? Your x is positive 1 according to the lower limit. Your x is positive 1, that's that positive 1 there. So if you plug it here, that will be like 1 is equals to 1 minus t. So you observe to say your t is going to be equals to 0. Or the same, if you plug it, if you get your y is equals to 2 minus 3t. Plug in, substitute the value for y. So for y, we observe to say on that initial point is a 2. So if you say 2, that will be 2 is equals to 2 minus 3t. That will give us t is equals to 0. The same thing is going to happen for the z. So we get to say your lower limit is 0, then you put your t, then let's find our upper limit. Okay, so we are still going to use the same functions. So for the upper limit now we are going to use b. So come here, I'm just going to use 1. Let me use y, then you can try to confirm with x and z if it will be the same. So I have 2 minus 3t here. So y is negative 1. Okay, y is negative 1. That would be like minus 1 is equals to 2 minus 3t. So we can find the value of t. This is going to, you can subtract 2 on both sides. That would be like minus 1 minus 2 is equals to minus 3t. So this will be like minus 3 is equals to minus 3t. Hence t will be equals to 1. So we have 1 there. You can actually try it out for with x as well as z, and I believe you're going to get that same upper limit. Okay, so having found the interval that we are going to use, let's go ahead and do the differentiating here. So x prime of t will simply be equals to negative 1. Then y prime of t will be equals to minus 3. Then z prime of t will be equals to minus 2. Okay, so if we put these in a square root and square each of them, giving more like a magnitude kind of thing. So this is going to be negative 1 squared plus negative 3 squared plus negative 2 squared. Okay, so this will be the square root of 1 plus 9 plus 4. What do we end up with? This is going to be square root of 14. Okay, so we have the square root of 14, something like that. Okay, so let's go ahead and utilize that. I'll need these. So here is now what is remaining is just a matter of doing the substitution. So here we're going to say we are integrating from, let me actually just place the square root of 14 outside. We are integrating from 0 to 1 as we have found. Then where this x here, this x, just substitute with what you have here is 1 minus t, and we say plus. Where this y, substitute with that, we have 2 minus 3t, plus where the z, we say 3 minus 2t, then dt there. You can simplify that. That would be from 0 to 1. So simplifying this gives us 6 minus 6t dt. How do I come up with it? We have 1 there, plus 2 plus 3 gives us a 6. Then we have minus 1t minus 3t minus 2t gives us 6t. So what do we do? Integrating this, we have like the square root of 14. I wonder why I'm writing 16. So integrating this, that would be like 6t minus, this is supposed to be 6t squared over 2, meaning it will just be like 3t squared. So from 0 to 1. So this will be equals to the square root of 14. Then just substitute the upper limit, the lower limit will give you a 0. So that would be like where there's t, you put 1, that would be a 6 minus 3. Okay, so this will be equals to 6 minus 3 is a 3. So the answer is 3 root 14. So this we are found to say is 3 root of 14, and this is our solution. So that's all in this video. Thank you very much for watching, and we'll catch you in the next video.